the new episode. And so, in the last lesson, we learned how to delete a node from the head and how to delete a node from the end of a list. Today, we will learn how to delete a node by its value. So, let's write our method. Public void delete by value. We pass a key and then we search the list, and as soon as we found that key in the list, we have to delete that node from the list. So when we say delete a node from the list, what does that mean? That means we have to set the connections between the nodes. We need to change the connection between the nodes. For instance, let's say we want to delete number 37 from the node. So what does this mean? This means first we need to find this in the list, and as soon as we found this in the list, so that at that time the important thing is that we should have access to its previous node, and we already have access to its next node because here this next already points to the next node, and the important thing for us is to have access to its previous node so that we can say its previous node has to point to its next node. This way we can delete a node from the list. Now this node is no longer part of the list, and the garbage collector will take care of this, will remove this from the memory, and that is deleted. So it is very easy, but the important step here is that we should find the key, and when we found the key, we should have access to its previous node. So that means like we deleted a node from the last, we needed two iterator, the current and previous, because if we consider this one our current node, so we should have access to its previous node. That way we can say its previous node has to point to the next of current. So let's write how we can write all the detailed code to delete a node by value. So first of all, let's consider some edge cases. One edge case is that it is possible that we have an empty list. So if a list is empty, we don't need an extra operation, and we say the list is empty. So we say if head equals null. So you already know that how to check if a list is empty. A list is empty when the head points to null. There is no node. So if the list is empty, we say system.out.println the list is empty, like this. Or sometimes it is also possible, it happens that our key is the head. That time also it is easy operation. We don't need any like difficult and complicated operation. We just check the head. That's also an edge case. So if it happens that our key is the head, so we already access the head and we don't need extra operation, we directly check that here also. We say if head.data, if head.data equals our key, that means we have found the key which is head. So we need to delete the head, and you already know how to delete the head. You just make head has to point to the head.next. That's easy. So you say head equals head.next. For example, if you were to delete number 49, so head points to 12, like this. Now 49 is no longer part of the list. It is very easy. But now in this example we are trying to delete number 37. It was just an edge case. So if these two edge cases are not met, then we start looking towards the list and check every node. So come here. So in order to do that, we need two iterators. One is the current to like check the current node, and also we should have access to its previous node, because I told you that when we find the key in the list, the important thing is to have access to its previous node. So let's say node current equals to head and node previous equals to null. Well, actually, we have already checked the head. We can start checking from here. So we already know that our key was not in the head, because here we checked that. And we removed that. We already say at this point that head equals to head.next. So I can say current should be head. So we start from here, current.next. Head equals current.next. You can start from the head, that's not a problem, but I think it would be more optimized way. And previous should be head. Something like this. Because we already checked head, it was not our key. So we don't need to check it again. Let's start checking from here. I think that way we even make more efficient code. So now we say while current dot so as far as current dot next is not null, we have to move forward until we find the key, of course. When we found the key, we have to end the searching. So we say while current dot next is not null, we have to keep moving forward. And at this point, that head is here. So when we say current dot next, is current dot next null? No, it is not null. It is 99. So now let's check number 12. If is it our key or not? So I'm saying that if we already checked number 49 in the head, it was not our key. Now we are checking this one. If current dot data equals key. So if current dot data equals our key, if we are looking for 12, so now here is the head or previous and it is the current. So we can say that the previous dot next equals current dot next. See, we removed number 12, but right now we are looking for number 37. So if it is not our key, then we have to move forward. So current has to come from here to here. So wait a second. We made this current first and use as head like this. At this point, I said current equals to head dot next. It is the head, and previous equals to head. And this at this point we checked the current, and it was not our data. So now we have to move current from here to one step forward, and previous also one step forward to this one. So we say current equals current dot next, or before moving current, let's first move the previous, like when it is like this. So before we move current from here to here, we have to keep its address to the previous, then we should move here. So I'm saying that previous equals current. So now we got the previous here and the current, we got the current in the previous, and now we say current equals current dot next. So current has to come here. So at this point the loop continues. is current.next null? So it is current, and current.next is not null. It is 37. So if it is not null, then is it the key? So we check, is current.data equals our key? If it was our key, so we could have said that previous.next, now previous.next points to the current. But we can say that previous.next has to point to the current.next, to the number 37. But there is not our key, so this condition is not executed. We go ahead to this part. Make previous equals current. So first take previous to current, and current to current.next at this point, like this. So now the loop continues. Now when we check, is current.next null? So current is here. Is current.next null? No, it is 68 not null. So if it is not null, is it our key? Is current.data equals to our key? It says yes. We are looking for number 37. So that means we have found the key. So now we have found our key. So we have its previous node using this prev, and we have its next node using the current.next. So we can easily say its previous node has to point to the next node, to its next node, to the current's next node, like this. So we can say previous.next, it is previous and previous.next equals to the current.next. See, it is current and its current.next is this node. Now this node points to this node, and we take out this from the list. So now that we removed that, so now that you have removed that, you can return that, or like it's up to you. You can keep that value in a separate variable, or let's do this now. Let's come out of the loop. So here we can say return current.data, and let's make the void to integer, something like this. So, or like if you didn't have anything, you could not find anything, you can say return data or 0. No, I think I mixed with JavaScript. That's fine. So return current.data actually you can do this here. And then here you can say if, because as soon as you say return, your function ends. So but at some points, if you could not find your key in the list, and you have searched all the nodes, so you say return 0 at that time, like this. So now I hope it was clear enough so that you should learn. Now, in order to test all these methods that we have developed so far, let's develop another method to print our result and see, like, does it really work or not. We have developed a lot of methods and we have explained all of them, but we did not test them, like we did not see the result on our list. So now let's develop another method to print the result and see, like, does it affect or not. So let's say public void print list. So when you print a list, you start from the head well, and you keep tracking all the nodes until the last one. So before going through a loop, check if the head is empty or not, because if the head was empty, if the list was empty, you don't need any extra operation, and you just say it's an empty list. If head equals null, system.out.println it is an empty list, something like this. But if head is not null, that means that is the time that you should start going through all the nodes using a loop and print all of them. So let's have an iterator, node current equals head, and you say that as far as this current.next is not null, that means we have to keep printing. While current.next is not null, we should say system.out.println current.data. So for example, at this time, is current.next null? No, it is not null. So print its value and go one step further. Say current equals current.next from to this one. And when you are here, is current.next null? No, it is not null. So print this value and move here. So is it null? Is this the next of this null? No, it is not null. So print this value also and move here. So when you are here, you check again, is current.next null? Again, it is not null. So print the value and move here. So now you are here. Is current.next null? It says now it is null. When it is null, that means the loop ends, but you did not print the last number. So you come out of your loop and print that also here. System.out.println current.data. So this way you can see the result. Now let's test them, let's put them in practice and see do they really work or not. So now if you remember, in our first lesson we created a linked list using a basic approach, but in real programming, like, we are not adding nodes like this. Now we have specific methods for adding a node either at the beginning or at the end of the list. Like here I was adding all the nodes to the end of one another, but it was like really taking time, and like first I had to create the objects and then add all the nodes to the end of the list and continue like that. So after this time, so now let's comment them. So we only create an object of this linked list, and now we have all the methods to add the nodes. So now, for example, let's create this node. So we have the object of the linked list, list dot first start like adding insert, let's list dot insert. So I have two methods, one is in the beginning and one is in the end, and like there, if you remember, we checked some edge cases, like if the list is empty, like right now we have an empty list, so it doesn't matter which one to call, that would be the first and the last and the only node. So let's take at the beginning 49. So I added one node in the list, because when I call this one, this insert at the beginning, first it creates the node and then check the list. See, like this, insert at the beginning. Where is that? Here. First it creates the node and then check the list. If the list is empty, so that is the head. But if it is not empty, so it takes care of all the rest of operations. So now let's print this. Like, could we really add that 49 in the list or not? List dot print, and let's see what happens. Like, it should print 49. Yes, so that means we have one node in the list. Or what happens if the list is empty? Yeah, it is an empty list. So in order to, when you are developing your methods, like, try to consider a lot of edge cases. Right now I developed some very general methods, but you take care of all the edge cases as well. So now we see that we have added one node and we could print that. Let's add number 12 also. Let's add number 12 list dot insert. So now here, if I say at the beginning, it would be wrong according to this picture. Like, there is nothing wrong with adding at the beginning, but right now we are saying that 49 should be in the beginning and 12 should be the second one. But let's check it. If I say add 12 at the beginning, so it should be like 1249. And if I print that now, first it has to print 12 and then 49. Let's check how it goes. Yeah, 1249. But now let's follow this picture and let's add at the end. List dot insert at the end number 12. This time it would be 4912. Let's check. Yeah, 4912. And then let's add 99 at the end. List dot insert at the end 99. Now add 37. List dot insert at the end 37. List dot insert at the end 68. Now let's print them, and it has to print all the list. Let's see. Yeah, it has printed all the list. So now let's test if we can delete or not. First, let's test delete from the head. So I'm saying that list dot delete from the head. So when we say delete from the head, it automatically delete 49. We develop that code here. Delete from the head. Yeah. So now let's test that. Delete this and print the result. So this time it has to remove 49. Let's see. Yeah, this time it has removed 49. And let's delete from the end also. List dot delete from the end. Let's delete number 68. So now it has to delete 49 and 68 and only print this one. So now let's print. Yeah, it has deleted this one, 68 also. Also now let me delete number 99 also. Delete by value. This time delete by value. And delete by value and pass 99. So this time it has to print only number 12 and number 37. Yes, number 12 and number 37. So these are all the methods, the general methods. Of course, you can customize these methods. They are like very general explanations. You can take care of any edge cases as well. And that's all for singly linked list. So in the next lesson, we will explain how a double and circular linked list work. Until then, have a nice time, everyone.